Aloha, welcome to Social Science 300. This is the first lecture for the scientific method. My name is Kanoa Meriwether, and I am the instructor for this course. The reading for this lecture includes Induction, Deduction in the Scientific Method by Irving Rothschild. You also want to read the 2 pages on Rene Descartes in 100 Essential Thinkers by Philip Stokes. And your optional reading is the Induction and Deduction article from the Internet Encyclopedia of Psychology and is the Scientific Paper of Fraud by Peter Medawar. The Induction and Deduction article gives you a very clear discussion of the differences between these 2 forms of logic. And is the Scientific Paper of Fraud is the article that Irving Rothschild is responding to with his Induction, Deduction in the Scientific Method. So what do we mean by science? Well, we're talking about a system of gathering information and a system of developing explanations about our natural world. It's not the only system that exists, right? But as a system, the highest value in science is accuracy and reason. Yeah. So because science values accuracy and reason above all else, and when I say reason, I'm talking about the ability to utilize the principles of logic. Yeah. So science tends to stand above all other systems of belief. It stands above, religion and mysticism and those sorts of things because of the applicability of scientific knowledge. And what I mean by that is science stands above other systems because it gives us the ability to predict the outcomes of events. And that gives us then the ability to construct a machine that, shows you videos and allows you to do email and all that kind of thing because we understand the principles of conductivity and electricity and all those sorts of things. And we can predict if we put things together this way, this is going to be the outcome. And that's an incredibly strong belief system. But science is not the only belief system out there. As I said, there is another belief system. The main competition for science as a belief system is religion. And religion comes to us from myth. Religion is actually an older belief system than science, right? Myth was the original system of explanation for our ancestors. The value of this system was not on accuracy, but rather on divine revelation. Yeah. So the idea with myth is not necessarily that you use that information to then apply to your natural world, but rather here is an interesting, entertaining story that comes from that you should not question basically because it comes from the gods. Yeah. So for example, one of an early myth is the Greek myth of Prometheus, and it basically tackles the issue of fire. It tells us where fire came from and why fire is so important. The Greek myth of Prometheus is basically the notion that, or is the story of Prometheus, who is a demigod who favored man above other creatures on the planet and wanted to gift them with something that would show how special they are. Man did not have fire, and it was one of the Greek one of the Greek god powers. Yeah. So he stole fire from Zeus. Fire was kept on Mount Olympus, and Prometheus stole fire and gave it to man. Because of this transgression, Prometheus was sentenced by Zeus to be chained to a giant boulder for the rest of eternity and have his liver pecked out each day by a giant crow. And each night his liver would regenerate. So the story here is basically telling us how important fire is, that someone would risk this and have to suffer this horrendous fate in order for human beings to have the ability to heat our environment and to use fire in different ways. So it's an entertaining answer, right? The myths are entertaining, yeah, but they aren't useful. They do not provide us information that that helps us to understand, what they're explaining, right? So, the myth of Prometheus is wonderful and fantastic, but it doesn't give us any applicable information regarding the nature of fire, where fire comes from, how to control fire, or any of the uses for fire. Yeah. So uh, we need something, an explanatory system that allows us to apply our understanding of the world and do so a in a logical manner. Well, regardless of how applicable religion is and how applicable science is, religion remains a very vital aspect of human culture, just about every human culture, in spite of our general acceptance of scientific principles. Yeah, and if you want to watch an interesting film on that, you can watch. There are two interesting films actually. One is Religulous, that is it's sort of a comedy documentary with Bill Maher, where he's kind of challenging people to support their religious beliefs. And but it comes from a reflective point of view. It's not trying to make fun of people or that sort of thing. Another film that sort of shows the power of religion and its strength even today is called Expelled, and that's a film that's narrated by the guy from Ferris Bueller's Day Off, who says Bueller, Bueller, Ben Ben Stein. Yeah, Ben Stein basically narrates this documentary that's looking at why creation theory and intelligent design are shunned by the scientific world. And he takes a look at how any scientist who tries to study intelligent design in a scientific way gets ostracized by the scientific community. So religion and science are still in competition, yeah. And although religion is an extremely strong belief system, we cannot use it to predict when a hurricane will strike. We cannot use it to understand how to generate electricity to power our homes. So although people tend to give religion plenty of space in their lives, when it gets right down to brass tacks, you don't pray to God to start your oven. Yeah. But both of these belief systems, lead us to a basic question, and this is one of the aspects of philosophy of science and basic epistemology, which is how do we gather information about our world? How should we look at our world and understand our world? Yeah. So one of the ways to gather information about our world comes to us from philosophy. Philosophy is basically the use of logic and reasoning to gain knowledge about our natural environment. Philosophy basically began with the Greeks in Western society. Yeah? There is Eastern philosophy and that sort of thing, but that's not what we're covering in this class. So the basis for science is logic. The basis for science is the application of sound reasoning to the information that we have about our natural world. This is opposed to something like idealism or supernatural causation, where rather than saying, well, it seems that the avalanche was caused by an overabundance of snow, we instead say the avalanche was caused by the wicked people in the town, and God decided to punish them and cause an avalanche to fall upon their town. So the difference, basically, what we're looking at here between philosophy and religion is the difference between idealism and materialism. Yeah, and this is looking at what are the causes in our environment? Are there natural causes or are there supernatural causes? So idealism basically is the claim that our reality is derived from supernatural entities that are beyond our comprehension. Yeah, from a god or the gods, whether it's Zeus and Mars and Venus and Hera, or it is, Jesus Christ or, Muhammad, or I'm sorry, Allah, and that sort of thing, yeah. So idealism is the perspective that supports spiritual systems of knowledge, which are religion, yeah. The other side of that coin is the view that reality is what has form and substance, and that matter is all there is. There's nothing beyond our comprehension. There's nothing supernatural in the world. There's nothing, fantastic or beyond our ability to understand, because matter is all there is. Yeah. So that's materialism, and that is the perspective upon which science and all empirical systems of knowledge is built. Yeah. The idea that we can understand reality. Reality has form and substance, and we can understand it. Yeah, that's materialism. A couple of other isms to talk about. One of those is what's called nativism, and that's basically the idea of where does knowledge come from. Yeah. Well, nativism is an answer that says that knowledge is an innate characteristic of human beings and of our brain. Yeah. So nativism would argue that we have cognitive abilities that stem from factors that are present within us before birth. Yeah. So nativism is saying that when human beings are born, we're born with certain abilities and certain faculties and certain concepts that are already set in our head, in our brain. Yeah. So nativism was an early forerunner to what's known as rationalism. And rationalism is the idea that new knowledge can be discerned just using rational thought alone. And we'll talk about that when we get into Descartes. Yeah. Another view of what knowledge is and where knowledge comes from is called empiricism. Empiricism says that rather than us being born with these concepts already set, empiricism says everything that we know comes from our senses. It comes from our experience. When human beings are born, we are born with a blank slate of a mind, and knowledge is imposed on our mind through our senses, through our experience. Yeah. So empiricism says you're born with a blank slate, and everything you know, everything you are, everything you're capable of doing is because of the experience that you've gained about the world through your senses. Yeah. So, pardon me. The dialectic here is a difference between the sort of the use of reason versus the use of senses and empirical exploration. Yeah. Can we come to new knowledge using just the power of logic and the power of rational thought? Or should we come to new knowledge by exploring our world, by making observations regarding the patterns of this world, and then going out there and testing and seeing whether or not these patterns actually exist and will do what we expect them to do? So where did we first get the split from myth and philosophy? Well, here in the West, our our best guess leads us to a Greek named Thales. Thales is credited as the first true philosopher and the first scientist because he attempted to find naturalistic explanations of the world without any reference to the supernatural. Thales argued that natural events occur due to some underlying order rather than the will of the gods. Yeah? So he said, it rains not because the gods are sad and they're crying. He says it rains because there's some natural pattern of events here that causes water to fall from the clouds. Yeah. So he was esteemed in his times as an original thinker, and he was an original thinker because he said, let's not, look for a fantastic explanation. Let's instead break with this tradition and just observe the patterns in our world. What can we learn by looking at the regularities, the way things repeat themselves over and over again in our world? So what are some of the things that Thales was able to observe? Well, one of his biggest breakthroughs was his ability to recognize that the Earth is a sphere, just based on his observations of nature and of the world around him. Yeah. So he was able to make various observations. One of those is that when there is an eclipse, yeah, when the moon goes between the Earth and the sun, the moon's shadow on the Earth is convex, and that would only happen if the shadow is falling on a round surface on a globe. If it was falling on a flat disk or a flat surface, it would be elliptical, right? Another observation that Thales made is that you could see stars in one locality and go to another, and those stars aren't visible, right? Well, then that makes sense if you're on a round surface, basically, that there are some parts of the sky that you can't see from some parts of the globe, and other parts of the sky that you can see. Yeah. Finally, his observations of ships as they leave. Right, when you're looking out over the horizon, out towards the horizon, you're watching ships leave. They descend gradually when you're observing them. First, you see the hull will disappear, and then the deck, and then the masts. Right. Well, that tells you then that they're traveling over a curved surface. Yeah. Because you're seeing it slowly. The surface is being left, and they're traveling around the corner there, kind of. And he also noted that a companion up at a higher point would see the ship for a longer period, and again, that would only occur if the Earth is a sphere. Yeah. So he's able to show the power of basic observation of our natural world, and then use that to predict. If he can identify the regularities, the way things work over and over and over again, then he can use that information to then go forward and say this will happen again, and it will happen this way. Yeah, and prediction is one of the major aspects that gives science its power over its competition. One of the most amazing things that Thales did was he correctly predicted a solar eclipse. Yeah, he didn't predict the day that it would happen, but he was able to say a solar eclipse will occur in the year 585 BC, and he was right. There was a great war during that year, and there are documents from that war that note that a solar eclipse occurred in 585 BC. He also identified the summer and winter solstices, yeah, which is basically saying what are the longest, what's the longest day of summer, what's the shortest day of winter, yeah, and because he was able to identify these two sort of polar opposites, the longest day and the shortest day, he was able to count the days in between and say there are 365 days in a solar year, yeah, just by observing his natural world. So Thales demonstrated for the Greeks the power of observation, the power of identifications of patterns in nature. These are the foundations for natural science, that we observe our world, we identify the patterns, and we try and recognize the relationships between events and objects that then give us the power to say, this causes that, therefore, we can predict when this happens, that will happen. Let's jump forward 1,000 or so years to Rene Descartes. Here's another amazing individual. This gentleman is known as the father of modern philosophy and mathematics. He founded analytic geometry, which is a bridge between algebra and geometry that Newton used to invent calculus and to do his work in the Philosophiae Principalis Naturalis Mathematica. So Descartes' reflections on the mind and body initiated the debate that continues today that's called the mind and body debate. And that's basically the question of what is the nature of the relationship between mental and physical events? Can we boil everything down to the mental, or is there something more? Yeah? Rene Descartes is the founder of continental rationalism, and he argued for rationalism as a method for understanding our natural world. the power of Rene Descartes' mind and his philosophy. Basically, his writings and the work that he did founded a movement known as Continental Rationalism in the 17th century. Continental Rationalism was a very powerful philosophy, and it was adhered to by the great thinkers on the continent of Europe at the time. There was an opposing school, though, that was known as the British empiricists. Yeah, and the empiricists argued a different viewpoint that we're going to look at in later lectures. So rationalism is a philosophy that argues that human reason alone can be the source of objective knowledge. Yeah, rationalism says we can derive new knowledge just from what we know in our heads right now. This is in opposition to the viewpoint of empiricism. Empiricism is the view that all ideas come to us through experience in the senses, that we don't have something innate in our minds that we can then use to deduce further truth. So Descartes started with what's known as methodological skepticism, and he said that if we are skeptical and we start with the very fundamental, intuitively understood principles, such as the axioms of geometry, we can deductively derive knowledge of eternal truth. Yeah. So, not that he completely discarded empiricism for the natural sciences, but he believed that the identification of eternal truth, things like mathematics, things like the resolution of the mind-body problem, that the eternal truths are attainable only via reason. So rationalism, from Descartes, argues that we can gain new concepts, new knowledge, independently of our sensory experience. How do we do that? Well, Descartes believed that we had a priori truth that is already set in our minds. Yeah, that we have knowledge and abilities already set there. Yeah. So he said that using the power of logic and the power of the mind is superior to sensory experience as a source or a method of knowledge, because of that truth that's already set in our brains. So he begins rationalism by examining all knowledge using what was known as methodological skepticism. That's basically doubting any idea that can be doubted, and challenging any idea or the source of any idea to meet the test of infallibility, which means, how do I know this to be true for sure? Yeah. He also asks, what are the sources of knowledge? He says there are two sources. There's what's already set, and then there's what we gain from experience. Those are known as a priori, which is your innate, self-evident, already set in your head concepts and ideas, and a posteriori, which is knowledge that is gained from experience. Which to trust? And he spent a long time looking and debating and going back and forth between these two sources of knowledge. Yeah, he says he wants to trust his senses. The senses are there for a reason, but they often mislead us. Yeah, he brings several issues to bear in this argument. He says, when you see a rainbow, there's nothing in the sky. There's nothing really there. Yeah, he didn't know at the time that it was light rays reflecting off of water vapor in the air. But he also talked about things that are half submerged in water. When you put a branch into a stream or a pond or something, it appears to bend or break. You can do that with a pencil and a glass of water, and it seems to no longer be connected. The most famous argument that he had against his senses was the wax argument. He said, I hold a piece of wax, and I seem to understand the wax to have certain characteristics, that it has this substance, that it has this firmness, that it has, these various characteristics. But when he brings it to a flame, when it's heated, all those characteristics change. Yeah. However, it's still the same substance. It's still wax. Yeah. Especially, it cools and it regains those previous characteristics. So he says, the true nature of wax is something that I'm grasping with the power of judgment of my mind, not with my senses, because wax can be either a liquid or a solid. Yeah. So he says, let's not trust our senses as a reliable source of information. Let's instead start with the basic truths that reside already in our mind. So here's an example of why he doesn't want to trust the senses. Looking at this image, some of you might see a duck. Some of you might see a rabbit. For those of you who originally saw a duck, you probably didn't see the rabbit until I mentioned it. Yeah? For those of you who originally saw the rabbit, you probably didn't see the duck until I mentioned it. This is known as an ambiguous figure. Yeah. So the issue basically is some folks can say, yeah, that was, oh, I saw a blue duck. Yeah. Other folks might say, I saw a blue rabbit. Yeah. Which one of those is true? Here's another reason why, or example of how the senses fail us. This here is an amazing, river gorge that, as you can see in the background there, they've got some sort of a concrete walkway around it and that kind of thing. But wait a minute, is it really a river gorge? No, it's not. That was a chalk painting. Yeah, that was that, and this is what it was painted over. Yeah, as you can see, the benches in the background, it's the exact same place. So our eyes told us, there's a waterfall, there's a deep gorge there, so on and so forth. Yeah, but what was really there was a completely flat surface. If you try and sail your boat on that chalk river, you're not going to get very far. Yeah. So we have many different reasons why maybe we shouldn't trust our senses. So if we reject sensory data as Descartes did, then we have to turn to those internal reflections that already must reside within us. These, Descartes believed were propositions that would be infallible. Yeah, and these would basically turn out to be axioms of nature. So, because he's using methodological skepticism, he's saying, "What can I doubt? I should doubt everything." Yeah, he says, what if God does exist? Yeah, but this is not a benevolent being. What if there is a supernatural being who is omnipotent, who wants to deceive human beings and keep us from perceiving the true nature of reality? Yeah, is that conceivable? Yes, it is conceivable. If so, then every single concept we have, every belief we have, even the fundamental aspects of math, could be the result of this omnipotent being manipulating our thoughts. And if so, then how do we get to any truth or any reality? Yeah. So this is a concept that Descartes really brought to bear that people have been wrestling with ever since. Yeah. And it's been used in popular literature and those sorts of things. One of the most recent examples of this argument comes to us from the comic books and the movies, the film The Matrix. Yeah. In The Matrix, we see a world where human beings believe that they wake up in the morning and they brush their teeth and they eat their breakfast and they go to work and they have relationships and they drink too much one night and they wake up with a hangover and they get married and they have children and all this other stuff. But they're really just lying in a big pile of goo with wires stuck into them. Yeah. And what they're having is a realistic dream. And the idea is that this is happening because there's a war between the computers and the people and blah blah blah. And that doesn't matter. What matters is though that we still have to ask ourselves this question. Yeah. how do we know the reality that we take for granted is really there? How do you know that you are not being deceived into believing that you're a student and a wife and a father and a worker and a son and a daughter, and you have this life and there are all these things going on? How do you know that you aren't in a pile of goo with tubes sticking out of you and that sort of thing? Yeah, that is a tough concept to sort of wrestle with, and it's one that we all get to deal with when we start asking ourselves, what is the true nature of reality? So for Descartes, he had to take it down to the most basic, fundamental propositions. Yeah, he said, okay, so let's say there is an omnipotent being who is deceiving me right now, and I am not Rene Descartes, sitting in my library, drinking a cup of mead and thinking about the world, or that sort of thing. I am, all the aspects of reality that seem so real to me, the firmness of this table and the warmth from the fireplace, can be complete lies, and they may not be true. But what I can basically say is I must exist. Yeah, I know. The fundamental proposition here is that I am thinking about this question. And to be thinking about this question, I must exist. So I am a thinking being. Yeah. The proposition, basically, that to be deceived, we must exist. So the proposition I exist is an a priori truth. Yeah. According to Descartes. So he says we can begin with this axiom: we must exist. No matter how powerful this omnipotent being is, for us to consider this question, yeah, of 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 what is reality? What can I basically say for 100% sure? The only thing I can say for sure is that I'm thinking, and therefore I must exist. So cogito ergo sum. I think, therefore I am. So Descartes' rational deduction, it's rational because it's seeking knowledge via reason alone, right? He's rejecting all sensory information. He's saying, I need to use philosophy, I need to use logic, and I need to break it down to the most fundamental truths that I can perceive. It's axiomatic. He's trying to identify statements that are self-evident upon which we can build other knowledge. Yeah, other knowledge though must rest upon these self-evident truths. Yeah, it's deductive. He's seeking to deduce further truth from the general axioms he identified, and we're going to talk about the difference between deduction and induction in a bit. So, I think, therefore I am, is Descartes' fundamental axiom, fundamental statement from which all other knowledge for him is built up. So in the Rothschild article, he discusses the scientific method. He talks about what exactly science is as a process. Yeah, he says science is an exploration of the world. However, as we saw with Rene Descartes, and as we will see with the empiricists, there's debate that continues as to the appropriate method for that exploration. But from Descartes, one of the things that we get is, in terms of our scientific perspective, is skepticism. Yeah, and of course that also comes from Thales as well. Yeah, here were people who said, no, I'm not gonna. I know this is a wise man and a holy man and that sort of thing, but I don't want to accept his explanation that God is angry and that's why there was a flood. I want to understand my world better, and maybe we can save some people, right? So skepticism. The idea is doubt without adequate proof. Go out there and find the evidence. Yeah, don't go out there and try and prove what you believe to be true, but instead look at the world from an objective stance and identify what's really going on. Yeah. That's one of the essences of the scientific perspective, that skepticism. Uh, and so one of the major models that we see being advanced in science is what's known as the hypothetico-deductive method, and that's what Medawar was arguing for in his paper, and what Rothschild sort of talks about in his. So the hypothetico-deductive model of science is a classical model of how science operates. Yeah, it's sort of what you think of when you think of classical science. That scientists begin with a theory about the world. This is a general statement, right? That says the world behaves in this way. Yeah, and then they deduce a hypothesis from that theory. And what that basically means is they're making a more specific statement based on that original theory, right? So if we say, the world is comprised of different gases, yeah. So therefore, we can deduce a hypothesis that we can identify these gases with the right technology and ability and that sort of thing, yeah. Then we can go out there and try and develop a way to identify what different gases exist out there and test that hypothesis. Are there different gases out there? So when we're conceiving of a hypothesis, yeah, it has to be falsifiable. Um, in science, we're never going to 100% confirm, a statement. Yeah, the term scientific fact is a misnomer. It's inaccurate. There's no such thing really as scientific fact. There are only conclusions that have yet to be falsified. Yeah. Um, the reason for that is because we've always got improving methods, improving technology that may disprove what we think to be true now. Yeah, and we're going to talk about why that is. Like for example, we want to say, the Earth is round, and that's a scientific fact. Yeah, and yes, that is something that all of our knowledge is based upon, and the way that planes fly and ships move and that sort of thing. 100%, we're going with that, and anyone who says that the Earth is flat is going to seem like a real idiot. However, we, the way things are now doesn't necessarily mean that that's the way that they're always going to be, and so we'll talk about why there is that argument out there. So let's move on. So we've talked a little bit about Descartes and deductive reasoning and that sort of thing. When deductive reasoning is a form of logic, basically, that science uses, yeah, and deductive arguments are those, basically, we can identify or describe a deductive argument as one in which the truth of the conclusion is 100% guaranteed by the truth of the premises. Yeah. So what that means is, if our argument is sound, the truth of our conclusion is contained within the original statement, the premise. Yeah. So as long as we don't go beyond the premise of our original argument, yeah, then we are good. We are golden. We can guarantee that our conclusion is 100% true. So what exactly am I talking about here? Let me give you a little bit. So here's a great example, because both deductive and inductive logic come to us from mathematics. Yeah. So we start off with a basic premise: all isosceles triangles have two equal sides and two equal angles. Yeah. So here's a general statement about all triangles. Yeah, that we label isosceles. Yeah. All of this group have this quality and this other quality. Then we go on to give ourselves another statement, right? That is, we're basically trying to deduce something from that first statement. Yeah. So we go and we look at a specific triangle. We find here, this is a triangle that has two equal sides and two equal angles. This specific object has the quality that we've identified in the premise, right? So if we are correct with our premise, and we are correct by saying that this triangle meets those qualities, our conclusion that this triangle is an isosceles triangle must be true. Yeah? So we can then use deduction to identify the properties of new triangles as belonging to isosceles group or not. Yeah? The truth always remains with the major premise, with the way that we identify isosceles triangles. And if we stick with that and we use that information correctly, if we make a sound inference from that, then our conclusion must be true. Yeah? As long as we're making inferences correctly and we're starting with a true premise, with deductive reasoning, your conclusion, therefore, must be true. So here's a bit of a more abstract example, maybe. What we're talking about basically is categories, yeah? So we're starting with a general statement. In deductive reasoning, typically, we're starting with a statement about a relationship or about a grouping, and we're saying, all members of this category have this quality. So we can do it with, sort of abstract and say all X have Y. This is an X, therefore this X has Y. Yeah, or we can try and put it into more sort of meaningful terms. All men, all X, have Y, are mortal. Yeah, all men will die at some point. Yeah, so that's a basic statement that sort of corresponds to the all X have Y. So then we can then use that general statement, all men are mortal, to understand something about specific men. Yeah, we can identify a specific man and say this is a man. Elvis, for example, is a man. Yeah, or whoever. And we can say, what we're saying basically is that this individual object or whatever it is a member of this category of men. And we've already identified that all members of this category have this quality of being mortal. Yeah. Therefore, if this is a member of that category, this has that quality. Therefore, although we hate to believe it, Elvis is mortal. Elvis is not hiding out somewhere in Tahiti, writing songs for Justin Bieber. Elvis passed away, unfortunately. Yeah, and then we can use that to go even further and say and identify that aspect for all members of that category. Yeah. Now, notice we're not saying all shapes. We're not saying all whatever, all living beings or whatever, because we don't necessarily know that. We want to be specific. We want to say certain members of a category, yeah, and that these certain members of a category also have this quality to it, or are also members of that category and that sort of thing, yeah. So, if the first statement is true, if we are using sound reasoning principles and we have a validly constructed argument, then we must be right. And that's the great thing about deductive reasoning, is if we do it correctly and we start from truth, then we must, therefore, be right with our conclusion. The way that most folks understand deductive reasoning is not necessarily with that idea that our conclusion must be true, although that is the 100% accepted definition, and that's the one that I want folks to adhere to. There's also sort of a common explanation of deductive and inductive reasoning that talks about the direction of the reasoning. Yeah? And so I also want you to understand those as well. So deductive reasoning typically moves from a general truth to a specific conclusion. Yeah? As we saw before, we're talking about all men. We're talking about, all Volkswagens have, rounded hoods or whatever you want to say. And what these are basically are reflections of repeating patterns and reflections of repeating relationships in the world. All men are mortal. How do we know that? Because all men die. Yeah, and that has not been found to be untrue of anyone so far. Yeah. So deductive reasoning opens with an expansive explanation. It starts with statements that are known or believed to be true, and it continues then with predictions for specific observations that should support it. Yeah. So when we're using deductive reasoning in science, basically, we're starting with a general expansive explanation. For example, we start with the theory of evolution. We say evolution is a universal biological process. Yeah. So with that general statement that's known or believed to be true, we can then construct predictions for specific observations. What predictions can we make based on that statement? Well, one of the predictions that we can make then is that human beings are a product of evolution. Yeah. And we can then go out and sort of look at, how does the human mind work? Is there any sort of evolutionary perspective that we can apply to this that would make sense? And what do you know? There is. And that's what we're going to take a look at when we look at evolutionary psychology. So deductive reasoning, the number one way to look at it is that this is something that gives you 100% true conclusions if you do it right. But it's also a form of reasoning that typically moves from general truths to more specific conclusions. In Rothschild's article, he talks about his view of the scientific process, and he contrasts that to the perspectives of Peter Medawar and Karl Popper. The reason that this article is assigned is because not only does it do a fairly good job of summarizing some of the basic aspects of science, but it also illustrates the lack of consensus in the scientific community with regards to some of the most basic issues in the scientific field. Yeah. So because there's this lack of consensus, uh, uh, you know, um, it's one that that most folks don't really think about when they think of science. They think of science as being this unified, unitary, group of folks who have all the same ideas and the same theories and the same sort of perspectives on the world. So what he's doing basically is he's responding to another article that was written by Peter Medawar. And Peter Medawar is a Nobel Prize winner in medicine. He won the Nobel Prize in 1960. So he wrote an article that argued against the use of induction in science and argues for hypothetical deductive system, the one that we just talked about in his article. He says that the form of scientific papers does not accurately represent the actual thinking and methods that take place in scientific study. He's saying that the scientific paper as it's presented is false because scientists do have an interest and a bias and a desire to have certain outcomes in their research. However, they present their research as though it's completely objective. This is because, pardon me, Medawar's saying that this whole sort of objectivity cult was started by John Stuart Mill, and he said we've got this value of objectivity to the extent that we pretend not to have an investment in the outcome of our research, and that is fraudulent because we become scientists because we have an investment in these questions and we want to find answers. So we've got an engagement here that is not objective. We're driven, we're motivated to answer, to explore our world and to find answers for specific questions. So he says when a paper is presented as completely objective and hey, we don't care if what we find is true or not or whatever, we're just looking at things, it's fraudulent. Yeah. We're going to take a look at this argument as well when we look at political science with Thomas Sprague's articles. He talks about the difference between logic in use and reconstructed logic, and that's the difference between logic in use is basically the process of doing science. Yeah, it's what we actually go through as we're trying to answer questions about the world. And so an actual scientific study is often very different from what we write up and present in our paper. That's what's called reconstructed logic, where we go back and we clean things up and we don't talk about all the dead ends and all the all the mistakes that we made and those sorts of things, and we just basically put it into a nice, pretty package for people to consume and accept as truth. So Medawar is saying basically that there's one kind of science that is good and another kind of science that is bad. That using inductive science is bad, and that using deductive science is good. And Rothschild is saying basically that whether we use inductive or deductive, it doesn't really matter. The point is whether or not we use rigorous methods and are strong with our logic, right? So under the foundation of science is basically the ability to use reason, yeah, to use our mind to identify qualities about our natural world. The reasoning that we apply is called logic, yeah. The forms of logic that science uses are both inductive and deductive, and we're going to look at both of those sides of the coin there, yeah. But when we're looking at, how do we then identify something as being scientific versus something, let's say, being pseudoscientific or religious or mythological or that sort of thing, we're looking at a way of gathering information and exploring our world that's based on observable aspects of our world, yeah? What we can see, what we can measure, what we can quantify, yeah? It's also based on empirical evidence, not what someone tells us to be true, but what we actually measure with our senses. Yeah. So it also needs to be some way quantifiable. It needs to be measurable. How big, how small, how much volume, how long, how short, whatever it is. We want to be able to quantify this information and subject it to these specific principles of reasoning. When science is being done, it's generally intended to be as objective as possible, because we're trying not to allow for our emotions to interfere with what's going on. We don't want to bias our interpretations of results. We want to be able to say that, I did this study and what I found was what I found, and it's I'm not saying it's good or bad. It just is. Yeah. Now that's easier to do when you're studying objective matter versus studying things like human beings who are not objective. And we'll talk about those issues as well. So, in the method of science, we're collecting data, collecting it through observation and through experimentation. Yeah, observation is looking out at the world, recognizing patterns and things like that. But also experimentation. Experimentation is saying, well, if this happens and I think it's happening because of that, then if I adjust that, this other thing will happen. Yeah, that's what experimentation is all about. Now, there are pros and cons to experimentation. We'll talk about those. But basically, the method of science is that we collect information and we formulate an educated guess about what's going on. That's what a hypothesis is. So, a scientific researcher proposes a hypothesis as an explanation of phenomena, and then we design experimental studies to test whether our guess is correct or not. We want these studies to be repeatable. We want people to follow the exact steps that we did and show the same results. Because if we can show that both studies done by different people found the exact same outcome, then the validity of what we say we're finding is much stronger. Yeah, then it's more likely that what we're finding is not due to chance, but because what we're saying is happening is actually happening. So Rothschild talks about the power of experimentation in science, yeah, and basically what he's saying is that experimentation has value because we can make our observations under controlled conditions, and if we do a good job of controlling the conditions, we can still say that what we observed is generalizable and is the same thing as what happens out in the real world. As long as our conditions, the conditions under which our observations are made can be identified and compared with one another, then the observations are valuable because other folks can set the same conditions and make their own observations. And if they come up with the same thing, then we've got a much stronger statement, right? So experimentation is great. We can do studies in the laboratory. We can control conditions and manipulate one variable and see its effect on another variable. And that's, and then we can write that up and say, this is what I did and this is what I found. Other people can repeat that, and they can say, hey, I did the same thing and this is what I found. And if you find the same thing, then your study is much stronger, right? You're saying, wow, well, what I seem to have found seems to be real because other folks are finding it too. So, but the ability to do experiments, and just because you say, hey, I did a scientific experiment, that doesn't necessarily mean that what you did was valid and worthwhile and that sort of thing, right? Any experimentation, the validity of any experimentation depends on whether you construct your experiment right. And that starts with asking the right question. It's also, an issue of your perspective on the patterns in the world or that sort of thing, right? Also, how accurate are our observations? How strong are we? How capable are we of making accurate observations? And then finally, how appropriate are our controls in this experiment? Are we doing a good enough job of holding these other variables constant? Yeah. So experimentation is one of the cornerstones of scientific method because of these powerful aspects to it. Yeah, that you can hold conditions constant. You can generalize to the real world. You can look at the effect of one variable on another while everything else is being held the same. But the problem, or it's not necessarily the problem for natural science, but that then produces one of the great gaps for social science, because in social science we cannot conduct the kinds of experiments that they do in natural science with human beings. Yeah, we cannot subject human beings to different states and measure them. Yeah, so if we want to study what is the effect of physical abuse on cognitive development, we can't say, let's take this 100 infants and subject them to a childhood of physical abuse and measure them each year. Yeah, we cannot do that. And some of the hallmark studies in social science are also well known as some of the great examples of why social science shouldn't be doing experiments with human beings. And we're going to take a look at those as we go. One of those is in your reading in The Tipping Point, and that's the Stanford prison study, where they took normal, healthy males and they made half of them guards and half of them prisoners, and they constructed a prison unit in the basement of a psychology building in Stanford. And this doesn't seem like it's unethical or anything like that. They weren't telling the guards to beat him or anything, but they had to stop the experiment after 2 weeks because the guards became so incredibly harsh, and basically it became unethical to continue the study. So we'll talk more about experiments as we go. But another aspect of science, and at the heart of the hypothetico-deductive method, is what's known as the rejection of the null hypothesis. Yeah, and that's basically saying, when you start out to do a research study in science, you have two hypotheses basically, right? When you're looking at something, you can say either this is occurring because it's being affected by this variable, or this is not occurring. Yeah. So that the null hypothesis is saying there is no effect, there is nothing happening here that's anything beyond chance itself. So when they do science, when you read a scientific article from a peer-reviewed journal, they're stating basically they're starting out saying that we expect there to be no event, no effect of the experimental variable on the chosen variable and that sort of thing. But because of that, we can never actually logically prove that our findings are 100% true. Yeah, because we basically know that all of our findings are judgments, are basically a matter of probability. Yeah, when you get right down to it, whether you're talking about deductive reasoning or inductive reasoning, the bottom line is we can never say 100% for sure. So therefore, especially in the hypothetical deductive method, your outcome, the strongest outcome you can have, has to be stated in a matter of probabilities. And probabilities are the realm of statistics. That's why all scientists and all social scientists have to understand statistics, because that's what we apply to our research to say this is meaningful. This is not occurring just because of chance. It's occurring instead because there's some effect of this variable on that variable. So all scientific research is basically, the outcome is basically saying we think this is a real outcome, and we think so because we've done the statistics that say that it does not appear to be happening due to chance. So finally, Rothschild also talks about, what do we do once we've concluded the study? Well, we share that information. We share what we did through documentation. That's what the peer-reviewed journals are all about. So documentation, sharing our data, sharing our methodology is done through publishing articles in peer-reviewed journals. The reason that these journals are called peer review is because every single article that is subjected gets basically reviewed by experts in the field. So if you want to do a study in cognitive psychology and say measure the amount of information that can be held in short-term memory for any period of time, you do that study and you write up your results, and then you submit your article to to the Journal of Cognitive Science, for example. Well, what they do at the Journal of Cognitive Science is they don't just take your article and say, wow, it looks, this person looks really smart, we better publish this. Instead, they have a review board, and the review board is made up of the best minds in that field. They send the article to those best minds, who then rip the article to part based on their logic and their knowledge, doing their best to reject any aspect of the article if they have any concern regarding the validity or the methods or the statistics or what they did. So most articles that get submitted to a scientific journal do not get published right away. Many of them, most of them, are returned to the author with the request to revise and resubmit. The experts in the field rip through the article as skeptics. They challenge the author's logic. They say, how do you know this is this? Why did you study it this way? Why did you use this test and not that test or whatever? Yeah. If they can find any holes or any chinks in the author's logic, they tear it apart. They send it back to them and they say, you address these issues and send it back to us. Yeah. So the author then addresses those issues and says, I did this because of that, and this made sense, and so on and so forth, and sends it back, and it gets reviewed again. And if they think it's strong enough, they finally publish it. So when you read an article in a peer-reviewed journal, you're not looking at just someone's opinion. What you're looking at is the work of not just that author, but the best minds in the field to review that information and to to review it with an extremely critical eye. Yeah. So this gives us a very strong test of validity. Yeah. When you get your study published in a peer-reviewed journal, that means that the logic that you used is sound according to the experts in the field. Yeah. And that also means that other folks are going to read your article, they're going to reproduce your study, and that's going to show whether or not what you found is real. The more your study gets reproduced, the more people can show that they did the same thing and had the same results, the stronger your evidence is. Yeah. So that's it for the first part of this lecture. I know it was a bit of a long one, but thanks for hanging in there with me. If you have any questions about the lecture, the reading material, or anything like that, feel free to email me or give me a phone call. I'm happy to discuss any of the material. Aloha and a hui hou.